video is a continuation from the HL paper 3, May June 2016, question 5a. And from that question, we had found that the Lorentz factor was 4.5. Now, in this question, we are considering the measurement or the distance that a detector has moved relative to the frame of reference of the electron. Now, we are going to have to consider something called length contraction for us to answer the question. So if an electron is at rest, so let's take an electron and then let's look at a detector at a distance and the electron is at rest. If we have an observer in the reference frame of the electron, we'll measure a distance from the electron to the detector of x1. However, if the electron is moving, so we have a moving electron, and in this case it is moving, and we have the detector, what happens is by the time light travels from the detector to the electron and the observer takes a measurement, the electron will have moved, and therefore the distance between the electron and the detector will have shrunk a bit. So let's call that x1 dash. Now, since the electron is moving, so when it is in a new position, again, relative to the detector, then the distance that will be measured will again be x2 dash, which is going to be shorter than the distance that would have been measured if the electron was at rest. So we have two distances. We have LO, which will be x2 minus x1, and this is known as the proper length that will be measured if the electron was at rest. But since the electron is not at rest, then the distance measured is actually x2 dash minus x1 dash. Now, to calculate L in terms of the proper length, we use the formula LO over, that is the proper length divided by the Lorentz factor. So that is going to be 0.8 over 4.5, which gives us a value of 0.178 meters to 3 significant figures.